A big thanks to Sound Imports for providing the components for this project. I'm starting off by calculating the required volume for each speaker on WinISD and creating a design for the enclosure. For this build, I'm using 10mm thick MDF board, which I cut into pieces for the enclosure according to the plans which you can find in the description of this video. With the pieces cut out, I measure and mark the positions for the speakers, ports, LEDs and sockets, and the amplifier and battery mounting points. I also mark the edges on the top and bottom panels, which I will trim on the table saw. This isn't necessary for the speaker, but will provide a more stable and airtight joint between the panels and will make it easier to assemble and glue together. Using a 35mm Forstner bit, I drill out the holes for the ports on the back panel. I then drill the holes for the charging port and LEDs. With a 3mm drill bit, I drill halfway into the front and bottom panels for easier mounting of the amplifier and battery board. With a hole saw the size of the speaker opening, I drill only halfway into the back side of the front panel so that I don't tear out the board once I do the final drilling. I'm using a router with a straight bit to remove some of the material from the inside of the back panel so that the LEDs and the charging port can be secured from the inside. I leave around 3mm of the board around the drilled holes. With the panels prepared, I apply a good amount of glue on the edges and spread it evenly. Because this is a stereo speaker, the enclosure is separated into two chambers and the hole in the middle panel will allow for the speaker cables to go through. There's no removable panels on this speaker, so I glue the front and back on the enclosure, making sure all corners are covered. And don't forget to include these corner braces before gluing the front panel like I did. Once the glue has dried, the clamps can be removed. Unfortunately, I lost the footage of rounding over the corners of the speaker once it was sanded smooth, but I used the largest round-over bit that I had on my router to trim the edges and finish them by hand with a sanding block. Here I'm applying a coat of PVA D3 wood glue over the enclosure and leaving it to dry while I do the same on a sheet of wood veneer. I am using paper-backed oak veneer and applying the glue on the backing of the sheet. After letting the glue fully dry, I apply a thin second coat on the enclosure and veneer, leaving a small section untouched on the bottom side of the speaker. When the glue becomes tacky, the veneer is ready to be applied on the enclosure. I start by placing the veneer across the center on the bottom side of the speaker. I then place a piece of fabric on top and use a hot iron to lock the veneer to the enclosure. Going slowly around the corners to make sure the veneer is glued well. I made the corners with a radius of around 20 millimeters, which I feel is the minimum size for the veneer to bend around nicely without splitting. Once the veneer is bent around all four corners, I mark and carefully cut the excess veneer along the initial edge. With the veneer applied around the enclosure, I use a flush trim bit to remove the excess. After trimming the excess, I sand the edges to make them flush with the panels. Repeating the veneering process on the front and back. After applying the veneer on all sides, I locate and drill a hole where the ports are and use the router to trim the veneer around the edge. After lightly sanding the edges, I locate the center for each speaker on the front panel and drill a 3mm hole. Because I want the speakers to be mounted flush, I will use my router jig to precisely cut the diameter of the speaker 4mm deep into the front panel. The locating pin is placed in the hole that's drilled on the panel and the jig is adjusted for the speaker diameter. Using a good quality hole saw, I drill out what's left on the speaker holes. With a fine sanding disc, I go over the whole speaker to remove any burrs and leave the surface smooth. After trimming the hole for the power switch, I covered the edges of the veneer on the bottom side and used a bit of filler to fill the gap. While sanding the speaker, I noticed the flaw that I made when rounding over the corners. Because the largest round-over bit that I had was a bit too small for the radius that I was aiming for, I further sanded the corners by hand, which made the radius inconsistent and therefore the veneer didn't fully adhere near the edges of the enclosure. That's why I sanded through the veneer on one corner. I thought I'd use some epoxy mixed with sanding dust, but decided to remove the veneer entirely in that spot using a heat gun. While it's definitely not the best looking solution, I decided to fill the spot with some epoxy mixed with sanding dust. After letting it cure, I sanded it smooth and moved on to finishing the enclosure. Here I'm using water-based semi-gloss varnish that I apply with a foam brush. I start by applying it on the front and using 2 cans of the same height, I flip it over to cover the rest. Once the first layer is dry, I lightly sand the surface to prepare it for the second layer. With the second layer applied, the surface is nice and smooth and it has a semi-gloss finish. I am now marking the holes for the LEDs from inside of the speaker using a sharp knife and carefully trimming the veneer around the drill out holes. With the speaker enclosure completed, we can take a look at the components that were sent by Sound Imports. Like for most of my builds, I chose Dayton Audio products, which include the amplifier, speaker drivers, ports, a battery holder, DSP programming board, and a bunch of cables. I even got a Sound Imports branded water bottle as a gift. For the speaker drivers, I decided to go with these full-range 4-inch drivers because of their compact size and good performance. These can handle 30 watts of RMS power and have a frequency response from 80 to 20 kHz, making them a great choice for DIY speakers. The amplifier is a Class D unit capable of delivering 50 watts per channel and has a Bluetooth 5.0 chip built in. To make the speaker portable, I will be using this battery board that can fit 3 lithium-ion cells and keeps the batteries balanced and protected from over-discharging. This is the KPX programming board that lets you unlock the full potential of many of the Dayton Audio amplifiers. It connects to the amplifier and your computer so you can preset equalization and other settings. These are the 1x4-inch ports and cables for the LEDs and other functions. Links to the components are in the description. A few cables and the included on-off switch won't be needed because I will be using this round switch with an illuminated ring inside and this metal socket for charging. I also won't include a volume knob because the volume can be adjusted on the audio source. The amplifier comes with clear wiring instructions, but before connecting the accessories, I will shorten the wires for my speaker first. After shorting the wires to the correct length, I am soldering the plugs from the green LED and the on-off switch. This switch has 2 pins for the LED inside and 3 pins for the power cables. The wiring is simple and will make the LED light up when switched on. After adjusting the length of the speaker wires and soldering terminals on the ends, I connect the cables to the amplifier according to the instructions. The battery board connects to the amplifier, following with the charging and auxiliary ports, the Bluetooth pairing button and blue LED, the red charging status LED, and the speaker wires, and finally the switch cables. Because there's no access panel on the speaker, the cables need to be installed inside the enclosure first through the hole for the speaker. After installing accessories, I apply some silicone for an airtight seal. The on-off switch is installed, held by the nut from the inside. Using some masking tape, I mark the location for the rubber feet and drill small holes on the bottom. I wanted the speaker to have a slight upright angle, so I designed and printed these standoffs for the front feet on my 3D printer. The battery board has 3 connectors wired together, so it doesn't matter which one is used. For the batteries, I'm using these high-quality 18650 lithium-ion cells made by LG with a capacity of just over 3000 mAh. Before installing them, I made sure they were almost the same voltage. I'm using small plastic spacers underneath the board and installing the cable through the hole in the middle first. The board is held in by 4 screws. Because I will tune the amplifier with all components installed, I connect the programming cable in the amplifier and will later connect the programming board once I'm done assembling the speaker. Since it is quite fiddly to locate the screws for the boards inside the enclosure, I am gluing the spacers on the board beforehand. I now push the left channel speaker wires through the hole in the middle, connect the plugs to the amplifier, leaving the programming cable outside. With the amplifier screwed down and the hole in the middle sealed, the wiring is finished. With the speaker drivers installed, I mark and drill out the screw holes. I now connect the drivers and use M4 screws to keep them in place. I am gluing a piece of fabric on the end of the board to stop anything from falling inside. I'm using an 18-volt power adapter to charge the batteries. When fully charged, the red LED shuts off and the speaker can be turned on. The speaker instantly connects to your device by Bluetooth. Before connecting the programming board, the USB mode is switched to the second position in order to connect to the software that I'm gonna use. The programmer connects to your computer using a USB Type-C cable. We can now open the Dayton Audio DSP control software and see if the connection to the amplifier is established. This software is easy to use and provides simple control of 10-band parametric equalizer, so you can adjust the sound of the speaker to your liking. You can also include high or low pass filters or a notch filter to remove a narrow bandwidth or frequency if you have unwanted resonance in your speaker. There's also an option to use a configurable compressor and a few effects like the noise suppressor, virtual bass boost, and a few others. While this software is fairly simple without many options of programming, a more sophisticated Sigma Studio software can be used with the programmer for many more customizable features. Because the learning curve for the Sigma Studio is much steeper, I will use the simple DSP control software to adjust the sound of the speaker to my liking. With the speaker playing, I make adjustments to hear the difference on the spot. With the equalizer set to my liking, I save the settings on the amplifier memory and the programmer can now be disconnected. To remove the programming cable from the amplifier, I pull out the port and disconnect it from the inside. After gluing a piece of fabric on the port and installing it, the speaker build is finished. Despite the issue of sanding through the veneer on one corner, I think the speaker turned out quite good. Thanks to the DSP programmer board, the sound quality is great and the speaker has loads of power for its size. I will leave you with a few audio samples inside and outdoors. I hope you liked this project and perhaps learned something new, and if you did, please consider subscribing so you don't miss out on my upcoming projects. Thanks for watching and I'll see you on the next one.
There was a boy, a very strange, enchanted boy. They say he wandered back